All right, we're taking a look at 3.1, two kinds of mixtures, and this is the start of chapter 3, which is mixtures and their uses. So remember this little diagram here. All matter can be sorted into two types of substances. We can have a pure substance or we can have a mixture. With pure substances, we can discuss whether it is an element, so just one type of atom, or a compound, a different mixture of atoms, but they are connected in one compound only. This could be like pure distilled water. Today we're going to take another look at mixtures. Now I've added the definitions that our textbook uses for mixtures here over top of our original ones, which are homogeneous and heterogeneous. So a mixture can be a solution, which is a homogeneous mixture, if you are curious, where all of the, there's multiple different pieces here. So we have one type of compound and another type of compound here, or maybe one type of element and another element. But in the grand scheme of things, you really can't see the difference. They're all mixed together really nicely, okay? And you cannot pick one out of the other. A mechanical mixture could be like a separation where they don't want to mix. This could be like oil and water. Or it could be one where we see the different pieces. So, I don't know, sand and aluminum shavings or something like that. You'd be able to see the two pieces there. So a mechanical mixture is when there appears to be more than one type of particle. Okay. So you can see the different substances in mechanical mixtures. Examples, like I said, like the sand and aluminum filings if you wanted, or shavings. But some more examples that are more concrete, things we use in regular life, could be a bowl of cereal and milk. I can very clearly see the milk, and distinctly different is the cereal there. And chocolate chip pancakes, I could see the pancake mixture itself, and I can see the chocolate chips. So I can identify two distinct pieces just with my eyeballs. That's a mechanical mixture. A solution is when two or more substances combine and you can't see the different parts. It looks uniform. You can't see the different parts with your own two eyes. So examples of this, shampoo, we know that there's lots of different things in shampoo. It's not just one compound. Ketchup is the same. There's lots of different things there. Laundry detergent, like liquid laundry detergent if you want. Iced tea, when you buy a bottle of iced tea, you can't see the iced tea crystals, which are made up of a few different things, and water. Most people buy solutions ready-made because it's more convenient. Some examples could be laundry detergent. Used to use powdered laundry detergent, and even before that, they would use a bar of soap and shave it. So we have slowly evolved to use a more concentrated version in water, just for convenience. Same with iced tea. Not very many people buy iced tea crystals and then mix it themselves anymore. Shampoo also used to be in a bar, and we have added it to water into a solution to make it easier for us to use as well. So different parts of the solution. Again, a solution, you cannot see the different parts of it. However, we know that there are two parts making it up at least if we were able to zoom in on a molecular level. So a solute is the substance being dissolved. Okay, so if we were making Kool-Aid or iced tea, it would be the Kool-Aid or iced tea crystals that would be the solute. We are dissolving them. Sometimes we could say that it is the substance in a smaller quantity. So I add a smaller amount of crystals, to the water that I'm dissolving in. The solvent is the substance the solute is being added to. The substance in larger quantity. Again, typically we are going to be dissolving into water. Not always, but that's the most common solvent in the entire world. So solute is what we're dissolving. Solvent is what we're dissolving it in. When I add a solute and a solvent, I get a solution. So when you make a cup of hot chocolate, what is the solvent? What is the solute? And what is the solution? So if I'm making a cup of hot chocolate, I have a spoon, and on the spoon, I have my hot chocolate crystals. If you're kicking it old school here. And so the solute would be my hot chocolate powder. I'm going to dissolve those into a mug of hot water. So the solvent is the boiling water. And when I mix those two things together, the solution is my hot chocolate itself. There's some little practice questions for you there on page 44, just number 1, 2, and 3.